Alright folks, hello and welcome to this mini lesson on absolute value and absolute value inequalities. First we're going to start with a definition of absolute value. What is the absolute value of a number? We're going to define this as you should have in Algebra 1. The distance of a number from 0 on the real number line. Okay, so the distance of a number from 0 on the real number line, you can see I have a picture above, and that's just a good working definition of absolute value. Don't just think it makes it positive, because then you'll end up switching the signs and things that we don't want. So for example, if you wanted to find the absolute value of 2, well, you look at the number 2 here on our number line, and its distance from 0 to 2, that length or that distance is 2 units. And since distance is always positive there, we will write the positive number 2 as our distance. So the absolute value of 2 equals 2. Similarly, the absolute value of negative 2, well, go over here, look at negative 2 on our number line. There it is. And its distance from 0 is also 2 units. Right? Remember, distance is positive, so absolute value is always positive. So that is also equal to 2. Don't get fooled by the order of operations. Remember, when you have these bars, the absolute value bars, they act as grouping symbols. So you'll always do everything inside them first, and then you will evaluate accordingly. So if you had a problem like this, well, you would do negative 2 times 3 first, because it's inside those grouping symbols. That's negative 6. But the absolute value, taking that, becomes positive 6. So this will become negative absolute value, negative 6, which becomes negative, or the opposite of the absolute value of 6. Well, the absolute value of 6, how far is 6 from 0? You go all the way out here to 6, and wherever that may be, we technically have to extend this line, maybe need a break, etc., but it's going to be 6 units away, and it will be positive 6 is the answer to this portion of the evaluation, and that means that we will just need negative 6 as our final answer there. So that's our definition of absolute value, and that's how you can handle dealing with those absolute value bars. Let's look at absolute value inequalities, or inequalities involving absolute value. So you might see something like this, or conversely, you might see something like 5x minus 3 is less than 7, or absolute value of 5x minus 3 is less than 7. So how can we handle these type of things? Well, the first thing I want to note is I don't really care what this expression is. Let me say that again. I don't care what that expression is. We're going to handle it the same way, whether it's complicated, whether it's simple. It just doesn't matter. Okay? So for right now, we're going to consider it as a blob. And by blob, it just stands for any old expression at all. So if you're taking the absolute value of some blob, and it's greater than or equal to 7, or the absolute value of some blob, and it's less than or equal to 7, or rather less than 7, then you're going to set up that problem in a similar way, no matter what the blob is. Okay, so let's look at this on a number line now, and we're dealing with an absolute value greater than or equal to 7, also one less than 7. So our key numbers here on our number line, all I'm going to put is really 7 and negative 7. Negative 7 and positive 7 are going to be the relevant ones as I think about this problem. Later on, you'll consider some other numbers. So in the first case, that's this one here. Oh, I'm sorry. There's my pencil. That's that one here. I decided, it's a little less sophisticated to talk about blobs in Algebra 2 Trig Honors. So why don't I, use a variable. So instead of a blob, I'm just going to call it z. So let's say this one means the absolute value of z is greater than or equal to 7. Where is that true? Okay, where is that true? Well, that's going to be true in several places on this number line. Where is the distance from 0 greater than or equal to 7? Well, it's equal to 7 here, quite clearly, because it's 7 units away from 0, right? This distance is equal to 7. But then we also just learned it's equal to 7 there at negative 7. So we know that those two dots that I have highlighted there, or these 2 points, are solutions to this inequality. But if we want to know where it's greater than or equal to 7, well, the distance is going to be greater than or equal to 7 as I move further away from 7, or in other words, as I shade this portion of the graph. And it's also going to be greater than or equal to 7. Let me just slide this over a little. As I move in the other direction, further away from negative 7. Okay, as I go this way, the distance from 0 gets greater. So these are the two relevant portions, and I would use those to complete or to finish solving this inequality. So I've recreated that below, on this next slide. And we can look now to solve this original inequality using our thinking inequality. The absolute value of z is greater than or equal to 7. So if we know that it's equal to, or that occurs in exactly two portions of the number line, this portion out here and the portion over to the left as well, right there, then we can set up or split our original inequality as follows. We can make two true statements and then solve normally without the absolute value bars. So it's either true that 5x minus 3, remember, which we represented as z, or a blob before, is greater than or equal to 7. Okay, that's this portion of the graph. Or it's true that 5x minus 3 is less than or equal to negative 7. So that's true because of this portion over here. And solving both of those inequalities, you'll get a compound inequality as your answer, which you can then graph. Let's look at the other case. Pull out our z again. Let's see where the absolute value of z is less than 7. On our number line, it's going to look very similar, except instead of going further away from 0, we want the distance to be less than 7. Well, that's not going to occur at 7 because at 7 it's equal to, it's not less than it. So I'm going to put an open circle there. And then I'm going to notice that anywhere less than that, as I go closer to 0, also on this end as I go closer to 0, those distances are all tiny. For example, I can pick a number here, maybe it's a distance of 2, etc. The distance from 0 is less than 7. So as long as that's the case, we know that all of this blue shaded region is going to be a solution to this inequality here. Well, we can use that fact to split up the original. Again, this time we have another compound inequality, and we can say that 5x minus 3 is less than 7, and 5x minus 3 is greater than negative 7. Now people have all kinds of tricks of remembering and or, remembering to just flip the sign, flip the number, etc., etc., and you're welcome to use those tricks, but I just like to think about it, because by thinking about it and using the number line, we can figure this out. An alternative way to write this would be this. Whenever you have an inequality that looks like such, it's bounded on two sides, you can take the left bound and say less than or equal to the expression in the middle, and then the right bound, which is 7. I'm sorry, I wrote equal to there, so let's fix that. And that would be an alternative way to write that, and you could solve either of those inequalities, and then you could graph your final answer. Okay, so thank you for watching this mini lesson on absolute value and absolute value inequalities.